Lesson 4.1 is on graphing equations in slope-intercept form. Okay, so in this video, you will relearn how to write and graph linear equations in slope-intercept form and model real-world data with equations in slope-intercept form. So the only vocabulary for this section is slope-intercept form. Okay, so now that I've said slope-intercept form like 20 times, what is it? So slope-intercept form is y equals mx plus b, and it's called slope-intercept form because it tells you the slope and the intercept. So the number in front of the x, we call it m, is the slope, and the number that's being added or subtracted to it is the y-intercept. Okay, so how do we take an equation in slope-intercept form and graph it? Well, if they tell us the slope, so remember slope is m, is 1/4, and a y-intercept we call b, is -1. So slope-intercept form is y equals mx plus b. I have m and I have b, I just plug them in. So y equals 1/4 x plus a -1, or we can say -1, so 1/4 x minus 1. Okay, so how do I graph this? So graphing something from slope-intercept form, you start with the intercept, the y-intercept. Oops. So you take that and you graph the y-intercept. So the y-intercept, remember, is where it touches the y-axis. So if it touches the y-intercept is -1, it touches the y-axis at -1. From there, we know the slope. So remember, slope is how much y changes, change in y over change in x. So if we have 1/4, that means it goes up 1 and forward 4. So from that point we drew, we go up 1 and forward 4, and we get another point. And we can think of it also as -1 over -4. So down 1 and back 4. And we get that point. You only need to do 1, but if you wanted to do more to help draw your line and make it a little more accurate, because I really struggle drawing a line, especially on this, but you get the idea. You connect your points. And that is graphing a line from slope-intercept form. Okay, so if we're given something like this, we can make it be in slope-intercept form. So to do that, remember, slope-intercept form is y equals mx plus b. So if we want to get it to look like this, we want y to be by itself. So that means I want to solve for y in this equation. So I'm going to do -5x. So I get 4y equals -5x plus 8. So y is not quite by itself, it's being multiplied by 4. So I'm going to divide each part by 4. So here they cancel, I get y, and then I have -5/4 times x plus 8/4 is 2. So now I want to graph this. So remember, the first thing I start with is my b, my y-intercept, which is 2. So that means it crosses my y-axis at 2. And then my slope, my m, is -5/4. So it means it's going to go down 5 and forward 4. So down 5, 1, 2, 3, 4, 5. And then forward 4, 1, 2, 3, 4. That's my next point. And so my graph is just going to be connecting those two. Guys, this is really hard on this writing tablet, but you can do it better on your own. Okay, makes sense? And again, you can also think of this as 5/-4. So that would be up 5 and back 4, which would give you the point somewhere up there. All right, what if I have something that doesn't have a slope? There's no, so slope-intercept form, again, y equals mx plus b. There is no term there. We only have is the b. When you have y just equals a value, that's just going to be a horizontal line, left and right. And it's going to be located at -7. So 1, 2, 3, 4, 5, 6, 7. And it's going to be this line down here at the bottom. Okay, so this goes like that both ways at -7. And that's that graph. All right, example 4. We should also be able to look at a graph and tell what the equation is. So we need, in order to tell what it is, we need M and B. So it's easy to start with B. You just look to see where it touches the y-axis. So in this case, it's touching at -3. So that means B is -3. And then I need the slope. So if I have this point here, I'm going to look to see if there's another point on the graph where it touches super nicely, like kind of the point. And this looks pretty good here. So from there, it goes up 2 and forward 1. So change in y over change in x, right? It goes 2 over 1, which is just 2. So that means my slope is 2. So I just want to take those two things and plug them into y equals mx plus b. So 2 for m, so I have 2x, and -3 for b. So plus and -3 is just -3. So y equals 2x minus 3 is going to be my answer. So b. Okay, example 5, write and graph a linear equation. The ideal maximum heart rate for a 25-year-old exercising to burn fat is 117 beats per minute. For every 5 years older than 25, that ideal rate drops 3 beats per minute. Okay, so we want to write an equation to find the ideal maximum heart rate for anyone over 25 who is exercising to burn fat. So if we're talking about linear equations, we're talking about being of the form y equals mx plus b. So we learned earlier in chapter 3 that m is slope, but we also said slope is pretty much the same thing as the rate of change. So looking at the information we have, rate of change is going to be how much it's changing by. And here it says it's a rate. So whenever you see like an amount per something, that's a rate. So 3 beats per minute, and it's dropping. So we can say that our m, in this case, is going to be -3. So drop means it's decreasing. So decreasing by 3 beats per minute. So we found m, which means that we want to find the b. So b is like the intercept. That's like the amount that it like starts at before it starts. It's the original. So for us, we're going to call that 117. So y equals -3x plus 117. Or if you want to think about it, we start out with 117, and then for each year somebody gets older, or for every 5 years, it drops 3 beats per minute, or whatever, which is going to be the same thing as what we had over here. Okay, so we want to graph that equation. So our equation was -3x plus 117. So -3x plus 117. So again, our intercept is 117. So let's say that these are going by 20s, 20, 40, 60, 80, 100, 120. 117 is going to be about there. And we'll say that these are going by 1, 2, 3. Well, no. This is not the best graph for this problem. Anyway, so for each beat, so this is -3 over 1. So for every 1 it moves forward, it's going to drop 3. Yeah, no, we'll do this one too. So it's going to go down 3. So if this was 117, this was 120 then, 100, 80, 60, 40. So from 1, it's going to just go down a very little bit and kind of go like that. And the next one's going to come down a little bit more. Anyway, so our rate is just going to be a super gradual decrease. It's really hard to draw on this, guys. Sorry. Okay. Find the ideal maximum heartbeat for a 55-year-old person exercising to burn fat. So again, we're going to use this equation. Y equals negative 3x plus 117. Okay, the thing to remember though is they said it was going down 3 for every 5 years. So if you're going from 25 to 55, that's a difference of 30 years. So divide that by 5, it's changed 6 times. So 25 and then to 30 to 35 to 40, 45, 50, and 55. So this was once, twice, 3, 4, 5, and 6 times. Okay, so it's really, our x in this case is really going to be 6 because it's 30 years of a difference. So y is going to be equal to negative 3 times 6 plus 117. So negative 18 plus 117 equals y, and you get y equals 99. So the ideal heart rate for somebody who is 55 years of age is 99 beats per minute. Okay, and that is it. Enjoy your notes.